Hello everyone, I'm Xuan from the Neurospin Computing Laboratory at the University of Texas at Dallas, and today I will give a brief overview of Skyrmion logic system for large-scale reversible computing. First, I will briefly summarize the concept of conservative logic. At the gate showing to the left, similar to billiard balls, the presence of the billiard balls is equal to logic 1 and the absence of the ball is equal to ball is representing logic 0. Here we have the input ports P and Q, each have a binary value. The port on the right outputs the corresponding value of this logic gate. If a single P and Q is equal to 1, the corresponding information carrier, in this case an imaginary billiard ball, will just go straight toward the output ports and, go straight to the output port on the right. If both P and Q are equal to 1, these balls will collide, and this elastic collision are critical to this reversible computing system. Assuming perfect elastic collision and a friction-free surface, no energy will be dissipated by this reversible computing system, and also while this system conserved all the energy by not destroying any information carrier. In this case, number of output billiard balls is always equal to the input balls. The signal gate on the right shows another example of the conservative logic gate. So what can be used as these billiard balls? Here we consider magnetic skyrmion as a perfect candidate. Magnetic skyrmions are two-dimensional quasi-particles that can exist at the surface between ferromagnets and a heavy metal. As the structure diagram shown here, and as we can see, we apply current in a plus y direction, which through some complex physics causes spin Hall force to push the skyrmion in this plus y direction. There is also a magnet force called skyrmion Hall effect that causes the skyrmion to move in the minus x direction over here. To control the motion of the skyrmions, we can use track structure with these walls on the side that repel the skyrmion and force it to stay inside the track. Finally, we will use skyrmion repulsion between two or multiple skyrmions. This structure is then used to implement reversible logic gates. Shown here is an AND/OR gate. This AND/OR gate is constructed with two skyrmion straight track and a junction in between. Skyrmions entering the A and B terminals on the bottom will be pushed by the spin Hall effect toward the OR and AND terminals on the top, and we will interact with it at the junction in the middle where the skyrmion tracks are opened, which is here. Again, the presence or absence of the skyrmion represents the logic value 1 or 0 respectively, and the number of input skyrmions is always equal to the skyrmion outputs. We can see the truth table is on the left. To synchronize these magnetic skyrmions, we have proposed this notch-shaped skyrmion synchronizer, as you can see in the diagram on the left. This notch here prevents the skyrmion from passing as it gets stuck at this notch because it's just too big. However, if the current density we use to drive the skyrmion is increased, the skyrmion radius shrinks, as you can see in the inset on the right figure. In that case, the current density pulse shown on the figure shown on the right will allow the skyrmion to pass through this notch. Combining different skyrmion logic gates and the synchronizer, we implement a pipeline skyrmion 1-bit full adder. The micromatic simulation video simulated by Mumax 3 show the skyrmion motions and interactions within the gates under different input combinations. The latency of this full adder is 2 clock cycles for the carryout and 3 clock cycles for the sum, with a throughput of 1 full addition per clock cycle. Here comes to the conclusions. Skyrmion logic provides potential for high-speed, low-power, and non-volatile computing, and it's highly scalable. And therefore, this conservative logic paradigm enables dramatically decrease power consumption by precluding the need to create or destroy skyrmions, which is super power consuming. Here are all contributors to this work, and thank you, and I will see you in the conference.